to all your students. So we are studying a new topic, that is measures of dispersion, and the very first thing we'll be discussing about will be dispersion. Okay. So consider two datas, data A and data B. If we sum up data A, we have the value of 200. Similarly, if we sum up data B, we'll have again 200. Okay, so both the sums are 200 each, but the values, the variabilities, the variables are different for data A as well as data B. Now if we plot a graph for data A as well as for data B, so this is the curve for data A, red is for data A and blue is for data B. So what do you understand over here? Here you can see the data A curve, that red curve is very much squeezed, but the blue one, the data B, is very much spread, isn't it? Here only you can see in the table only data A, the minimum value is 10 and the maximum is 31, but in data B the minimum is 2 and the maximum is 40. So data B is more spread, but data A is not that much spread. It is a bit squeezed. Okay, so variation is very much less in data A, but it is more in data B. Okay, the measure of dispersion help to interpret the variability of data, that is to know how much homogeneous or heterogeneous the data is. Okay, so data A is more homogeneous as compared to data B. In simple terms, it shows how squeezed or scattered the variable is. Okay, so you can say the variable for data is more squeezed, but for data B it is less squeezed or it is more scattered. Okay, so measures of dispersion are basically of two types: absolute measure of dispersion and relative measure of dispersion. An absolute measure of dispersion contains the same unit as the original data set, whereas for relative measure of dispersion, these are used to compare the distribution of two or more data sets. Okay, so absolute measure of dispersion means they'll say whatever the data is, but in relative measure there will be comparison. Okay, like suppose we have got two kids, John and Sam. John have got 40 marks and Sam have got 45 marks. So who is better, John or Sam? Obviously Sam. Okay, so because he got 5 marks more as compared to John, so we all want to be Sam, isn't it? We all want to be a good scorer. Okay, so you also want to be Sam? Yes. Okay, fine, but that was absolute measure. This is the marks they got. Next we'll check out regarding relative measure, where there will be comparison. So John got 40 out of 50, whereas Sam got 45 out of 100. So which one is better, John or Sam? John, isn't it? Because his score is almost 90, more than 90%, but Sam less than 50%. Okay, you can say directly 45%. So you don't want to be Sam, you want to be John. Okay, so how you understood? By relative measure of dispersion. Okay, so in absolute measure of dispersion, you will get to know the exact value, whatever the data is, but in relative measure of dispersion you will get a actual figure, because here there will be comparison, and because of comparison you will get to know the actual thing. Okay, the absolute dispersion method expresses the variation in terms of average deviation of observation, like standard or mean deviation, but over here this measures compares values without units. Now we have got few types of absolute measure of dispersion, such as range, variance, standard deviation, quartile deviation, mean and mean deviation. Similarly, for relative measure of dispersion, the types are coefficient of range, coefficient of variation, coefficient of standard deviation, coefficient of quartile deviation, and coefficient of mean deviation. Okay, so this was all about the topic regarding dispersion. In the next video we'll be discussing all these things, whatever is there in the syllabus. Okay, I hope you people found this video helpful. Thank you for watching.